name is Etienne Caron. This topic is a bit different than my usual subjects in the sense that I'm going to talk about a bit more social things than my only technology today. So this talk is entitled Mixed Reality for Social Good. So we're going to look into a few definitions here. So Wikipedia tells us that mixed reality is about mixing the real and the virtual. So that definition covers what we usually call virtual reality and augmented reality. So that definition appealed to me for a couple of reasons. If you look at the VR and AR platform landscape right now, so there's a lot of impressive technology. But you can still argue it's early days, still early days. For me, personally anyway, it's hard to tell if this is just a fad or the next big tech disruption. And we've been hearing about VR for a while, right? But if it's a fad or not might be beside the point. So if you think about the history of it, in 2011, there's an 18-year-old kid that built a prototype VR headset in his garage. In 2012, he has like a successful Kickstarter, starts a company. 2 years after that, Facebook buys that company for $2 billion. That's what we're looking at. But it's not really a story about a whiz kid alone in his garage, working in a vacuum. That success would never have happened without community. This story is really about community. So if you think about it, we're talking about VR and AR because of the smartphone revolution. The right parts became available around 2010. Hobbyists took notice, and they revived a very old idea. Depending on who you talk to, VR and AR is old, been like around for 100 years. So social good, having a positive impact on society. For me, that's where the real magic comes in. So you get together with people from the community, you make friends, you learn new things, you experiment, and the potential to create something new, super inspiring to others, is definitely there, right? It's in the community part of it. So this idea of social good then, how can VR and AR really bring about social good? Well, you can look at direct applications of the technology, right? So VR is a really awesome learning tool. If you think about geography, the VR edition of Google Earth is a great example. Just for fun, who here has tried the Vive edition of Google Earth? All right, so about a third of the crowd. I really recommend you try this out. It's mind-blowing in all the right ways. Like, if anything is going to make you see the potential of VR, this is it. It turns what could be a boring and mundane topic into an eye-opening exploration of the world. It's really that good. If you want to create, for example, a time machine to explore historical events, this is exactly that type of installation that's hosted at the Palace of Culture and Science in Warsaw, Poland. You could build any type of simulation. You want to navigate to the heart of the atom, like you want to see math equations come to life, stand inside a running engine, possibilities are endless, right? And there's actually possibly more benefits to presenting material in that way. So this is a link to an article by Chris Nicholson. He's a researcher on Shopify's VR team. So I work for Shopify, and by the way, I'm not at all associated with the VR guys. Like I talk to them once in a while, but they do really exciting work. So this article specifically, I really think you should check out because in it they explain how that humans are visual and spatial learners, right? So to illustrate this, the best way is to think back on your own high school years. Depending on your age, it might be difficult to remember the names of your classmates. But I'm betting you can all pretty much remember what the layout of the school was like. You can probably draw it out. So that really illustrates that we learn through visual recognition, right? So if you can create virtual spaces that leverage that effect, you will definitely get students more interested. In the field of journalism, we've seen very compelling use of the medium. So what's life like if you're fleeing from a war zone? What's the daily life for a volunteer in a far-off region of the world? And finally, we can think about healthcare. There's been a lot of research on how to use VR and AR for treatments. Relaxing patients that are suffering from chronic pain, such as what the patient has pictured here. Exposure therapy to treat phobias. Rehabilitation therapy. There's a lot of promising areas of research in that field. So VR for Impact is an umbrella organization that's dedicated to the use of VR towards doing a positive social impact in the world. But I have a question for you here today. Who stands to benefit most from these advances in education and healthcare? Quality VR experiences are both expensive to produce and expensive to consume, really. So we've talked about journalism. On one hand, by walking in a mile in another person's shoe, you can hope to build empathy towards those people, right? But are Facebook, HTC, and Google trying to help refugees all around the world, really? Or are they advertising a new high-tech toy that's built for the 1% for us? Ultimately, either way, the technology has great potential for good. But potential is only that, potential. At the core, does it even matter what type of technology we're talking about? Does it even have to be about technology? Sustainable social good, in my opinion, is about community first. So with that idea in mind, in my hometown of Montreal, I'm a volunteer for an organization called the Cosmos Academy. So the concept is that passionate people come in, they learn about an emerging technology, whatever it is, VR or otherwise, and apply it in the field. So community being about building bonds with others, you will still have usually a common interest that will be the focus of your community, right? But what you have to keep in mind is that good communities strive for diversity. So diversity of backgrounds and life experiences will help to make for better learning experiences for everybody. So you can see the ideas reflected in this chart right here. So one of the Osmos Academy's projects is called VR Passport. So that project brings together brings over virtual reality experiences to kids in hospitals. So it's a way for them to learn about the technology, visit new places, and it gives them a small break from the hospital, something that's usually very appreciated. We've had a lot of positive feedback from that stuff. So on the other flip side of the actual visits, in preparations for these, we have VR content creation workshops and courses that we organize. We have kid-friendly workshops where participants could decorate Google Cardboard headsets that are pictured here. So these would be brought on the hospital visit to make the tech a little bit more fun, and it's a nice way for the kids to get involved. So what's really interesting about this field in general is how it allows you to be creative. You don't have to be a programmer to participate in these workshops. Artists, designers, crafters, developers, there's a multitude of roles that can be taken on. And in many cases, these are open to beginners all the way to experienced veterans, like probably most of us here today. So let's talk about building things. What does a mixed reality project look like? So as you might expect, it's a mixture of various components. And that's actually a super good thing for community building. The wider the skill set needed, the more inclusive you can be. So the demo project I'm going to show you today includes multiple components. So the first one is a real-world Lego model that reflects a virtual model that is going to be built. We also have an Android Things-enabled Raspberry Pi. So this enables you to bring physical reactions to the virtual reality interactions. So we have a VR experience that's running off of Google Daydream's platform. That's mostly what we're going to talk about today. That's a big part. And we also have an AR terminal, which having a slide defect. But anyway, so we're going to have a small AR terminal that allows somebody to look at the model, the Lego model, and interact with it using through the magic window of the phone. We'll see some more screenshots later. Okay. So the physical Lego model. You might be wondering why you have a physical model. That's a big deal, right? The inspiration for this came from this Audi mixed reality experiment / commercial. So the idea is to scan a real life model and you drop the players onto it. So the end result is wonderful, right? How cool is it to become a miniature race car driver? Who would not want to try this? But while you're watching this clip, step back a bit and think about the bigger picture. Put your community organizer hat on. it's really awesome project. Kids are playing around in the sandbox. You can put together a race car simulation rig, a physical one. There's 3D modeling, scanning stuff with the Kinect, programming a VR simulation. There's a ton of skill sets needed, right? From anyone can do it to full-on expert level. And more importantly, it's not a solo project, right? You need a lot of people to make this happen. So this is very good as far as a community project goes. That's something you can rally people around. Another big source of inspiration came from this game right here. So who here has not heard of Keep Talking and the League of putting on the spot a few of you. So it's a cooperative game, which is one of the nicer things about it. So you have one player that's in a virtual room, and they have a ticking time bomb that they must defuse, right? So the other players in this game are the experts. Those are the ones that, oh, it's not video playing. Try again and I'll give up here. All right.
Okay, I see a bomb. It's got wires, a button, keypad. So we're gonna go wires one by one, left to right, okay? The first wire, does it have a light on the top?
It does not. Instructions to the player. So the way this works is that they need to decipher a very funny bomb defusing manual to find out how to help their teammate, right, their VR. So the catch is obviously they don't see the bomb. So the communication between the players is super important. It's key to win. And that brings me to a thing that most of you probably know intuitively. VR headsets have a very obvious downside. Once you wear your headset and your headphones, you're absolutely isolated from the people around you. So that's not great, right? That's not a very social thing at its core. But if you're creating mixed reality experiences, you're really doing the opposite at this point. You're creating a very shared experience. So if we get back to our project, the idea is to build an interactive model and to link this VR simulation and use this AR magic window to have players interact together. So you might be thinking at this point, 3 platforms, how did I get to talk? How to get them to talk to each other? And Firebase is an obvious answer for a quick MVP. This is not a Firebase talk, so I'm not going to go into details. I'm guessing a lot of you have had exposure to Firebase. Like, who's not familiar with Firebase? Pretty much, yeah, that's it, right? Everybody knows. So general idea is just that you have this model, and all your components are going to subscribe to the model in the Firebase real-time DB and get updated. Latency is usually pretty slow, so for an MVP, this is pretty good. All right, so next slide. Oh, terrible. So what's our story here? Mr. Halloween guy wants to go say hi to his friend Birdie. There we go. All right. So he's all the way in the corner, right? To get to go say hi to Mr. Birdie Buddy, we need to open 4 different doors. So the person wearing the headset will be playing the role of the Halloween guy right here. The person outside the simulation will help the character when he faces obstacles on the way. So since this is very much more of a concept demo, the only obstacles are going to be doors that are in the way. So imagine for a second that these white blocks, these white Lego blocks are the doors that the character has to go through before getting to his friend. So the Daydream simulation is where a lot of the action narrative is happening, so we're going to explore that. But first we're going to look quickly at what the AR window experience will be made of. So I kept things relatively simple for the AR terminal for today. I use Project Tango in my example. So with Tango, you do have a Unity SDK that's available. If you use this, there's a big advantage in the community sense because people typically, even non-programmers, when onboarded into Unity from experience, are usually pretty quick to adapt and actually generate stuff and generate content. And what's nice here is that if you do use Unity for your own projects, you're going to be able to reuse the same assets for your VR and AR experiences, right? So it's probably a good idea if you're aiming to start your own community-based project. In my case, the Magic Window setup is actually a typical Android project. The reason for this is, for those of you who might have been to the White Mount New York or watched the videos, I've done a presentation there in the past where this was actually the subject. So I just reused that code, being a lazy developer, as a lot of us should be. So here, there's an associated GitHub that you can find if you look at the link. So you can just lift the code from there. And if you're project team has a strong Android focus, which might be the case since we're all here in the same conference, you might benefit from this book too, so I encourage you to look into it. All right, so the basics are if you want to allow your players to send door keys, or to send objects that will help the player in VR unlock these doors on the way. All you need to do basically is add little buttons on your UI that will say what you're dropping into the virtual world. So then if you say select red here, you can drop red platforms, or red cubes, or red keys, or red objects into the game world that the VR headset wearing person will see appear through the communication over Firebase, right? So, there's a lot of nice improvements that you can do. You can try to map out only the objects to throw into VR. You can try to, if you have your model in front of you, map out where the virtual characters are in the scene. There's a lot of work there that can be developed on. I won't go too much into details today again, but you get the point. So, a last note on AR. While Tango is great, it's not yet what you call accessible hardware for everybody, right? And so a good replacement could be this project. So this is, the developer is called Etienne. He has a 3JS web AR extension that he's built that works at 60 frames per second, as you could have seen, in the video, working on 2-year-old phones. So this is really exciting stuff. Like, it only came out in the last few. His particular project was published, I think, a few months ago. And I believe that the F8 conference had also an angle on this kind of AR approach. So I believe he was there and watching his Twitter. So he's a very interesting person to follow on Twitter for all this. What's interesting about these projects in 3JS and WebAR and all these things is since they work on phones and they're in the browser, you can take JavaScript developers that are interested in 3D and leverage their skill set and bring them into your community, into your project. That's also a very interesting piece of stack that you should look at if ever you get started into this. All right, so let's move on to VR, Daydream, and Unity. So there's a few notes on setting up. Now, I'm not going to bore you into the tiny little details of how to set up all this. There are a few notes and a few gotchas I want to cover with you so that if you do get to follow this tutorial and start, you won't get stuck or run into the same problems I did in the last few weeks. So you should note that the latest version of the Google VR Unity SDK is best used with a fresh installed Unity 5.6. That's often a thing I've noticed in our community projects. People have limited time, so we might meet once every 3 weeks, every month. And quite typically, the first few hours sometimes can be, oh, they've updated the SDK, so we need to start projects from scratch. So it's always a good thing to start fresh because you don't know where it'll be in a month from now. All right, so, and if you're day-to-day Android developers, there's a couple of issues you should be aware of. So this is the time where I encourage you to take out your phone and take a snapshot of the slide. Oh, wait. I'll just talk while you do that a little bit. So the big story here is that under the hood, Unity's latest version is still expecting an older version of the SDK tools for Android. So you're going to want to have a separate SDK install for Unity than from your day-to-day development environment, trust me. The trick is simply enough to grab the appropriate zip for your platform, right? And those are Mac. Then you configure Unity to use that install instead. So when you use these zips, you're only going to have the /tools folder of the SDK. So Unity at least is a bit clever about this. It will use this and download the API levels it needs to get its job done. So it's not such a terrible slop, even though this slide is very scary. Once you're done with that, you might run into an issue with the Daydream controller emulator. So the Daydream controller emulator is pretty vital when you're developing Daydream experiences with Unity. It allows you to use your phone or your actual Daydream controller to point in the Unity simulation, right? So you don't have to constantly build and rebuild and throw the APKs onto the phone. If you think, Android Studio is slow and you don't have instant run, Unity is definitely not fast enough. So you're going to want to do most of your development in the emulator on the Unity side using that. So to fix the problem that you're probably going to run into, you're going to want to edit a emulator client socket.cs file that comes with the Google VR SDK that you can be throwing into your own project, as mentioned on the slide here. So it's a one-liner change. It basically looks for ADV in the wrong place if you installed it in a different place. So it's fairly easy to change. And so I hope those of you that want to take this snapshot have, because I'm moving on to the next step. The other thing I recommend to people is to install the new JetBrains C# IDE called Writer. So those of you that know me might know that I'm usually I usually put a little diss on Unity in one of my slides, typically. And the main reason I've been doing this, if I'm absolutely honest, is that I hate mono-develop. And mono-develop is the IDE that comes bundled with Unity. If you are missing the good old days of Eclipse, you might like mono-develop. I personally like the power of the JetBrains suite, so I'm very happy now that this is finally available for Unity on Mac specifically. So get this, and you'll get all the powerful features you're used to, and it makes development in Unity 8 weeks, at least coding. All right, if it's your first time trying Unity, on your own time, I recommend you spend a bit of time with the rollerball tutorial. So that one teaches you the basics of the world editor. You're going to see how to add 3D objects to a scene. It's going to teach you the basics of camera, lighting, and materials. I can tell you that a lot of people without previous programming experience have gone through this tutorial and had great success. That's also a really nice thing to give to volunteers if you want them to be active in the project. You also learn in there how to add scripts to game objects, how to apply physics. So it's a very good hour, it's a very well spent hour before you go into the Google VR SDK. Just for my own curiosity, who here has some Unity experience? All right, cool. So, all that being said, once you get into Google VR, things are not very complicated. So don't worry too much, right? If you spend this hour, you're not going to face days and days of learning. Using the Google VR SDK is straightforward once you're familiar with Unity. So first, you're going to be adding something called the GVR Viewer Main prefab to your Unity scene. So for those of you who are not familiar with Unity, and you go through the rollerball tutorial, you'll learn about this, so don't worry too much if you forget the details. But Unity has this concept of prefabs. So they're basically objects that can be dropped into any scene. You can think of them a bit like class declarations for complicated 3D scripted game objects. So if you have a player object that's animated and that has certain rules about how it animates itself, you can create a generic one, which will be prefab, and you'll drop that thing in all the scenes that you want that player to be in, for example. Right, so the GVR Viewer Main is a prefab that, once dropped into Unity, is going to provide you with full stereoscopic 3D and head tracking. So in this simulation, note that you can use the mouse to control the head movement of users. That's you press Alt and move your mouse button, and then move buttons. All right. So, so to use the Daydream controller, you're going to add the GVR controller main prefab to your scene. It's another one that comes with the SDK. Under the UI prefab folders, you're going to find also the GVR controller pointer. So that is to be added to your player object. So you can actually see the controller once it's added to the scene. So it's kind of fun to be able to edit things in a very visual way, right? So you drop that prefab, and this is the controller you're going to get. So once we install and bring up the controller emulator app on a real device like this, we're going to get control of that controller. And okay, so at this point, we can use the phone or the actual Daydream controller to move the pointer up in the scene. And so we can start prototyping and interacting with our scene. All right. So we go back to Mr. Alvingau and his birdie buddy right here. So we haven't put the doors in yet in the actual Unity scene. So you're going to have to use your imagination a bit. So how will we, Mr. Alvingau, move about the board to get the birdie buddy, right? So the baseline locomotion mechanic in VR is usually some form of teleportation. So there's a detailed tutorial on how to implement this in Unity, which I probably forgot to put the link on the slide, so you're going to have to hit me up after the talk, and I'm going to give it to you. But if you're curious, it's actually a Google developer that's building it. I think he's called SDK Boy. So that URL, sdkboy.com or something like that. So if you Google that, you'll find these tutorials. So he's built a full tutorial that explains how to do teleportation. We're just going to skim over it and look how it generally works to give you an idea. So when you use Unity, the general idea is to assign a script to the object that will react to a click in our case. And once that's done, using something called event trigger components, you can register interesting events. So it's very much like a click listener, if you will. Right? So here we're controlling, we're listening to pointer enters object, pointer leaves object, so you can see that the teleport pattern are lighting up when you point on them. When you click on them, we saw that the player teleports to them. Right? That's usually a few lines of code and knowing how to assign scripts. So if you've done any OpenGL programming and you haven't used Unity yet, you can see that it's actually very, very quick to prototype, and you can also understand how volunteers without necessarily a ton of experience can use this pretty effectively. Right, so now that we have locomotion in place, we want to add locked doors to the scene. So to make things more interesting, right now we're using colored blocks as keys. So imagine these colored blocks on the right are the keys to the door that are on the left, right, that are lit up. So those are the doors and those are the keys, right? Okay. So now what we want to do is pick up one of those keys and use it to unlock the door, right? So we're going to need some sort of way to pick up that key. And we're also going to want the door to open once we click on the door, right? So we're going to look into the details of how that works. Again, I'm not doing a deep dive here. I just want to give you all the general flow. And when you do this on your own leisure time, you're going to have a fairly clear direction to follow. Like usually the bigger parts, the longest, sort of the bigger challenge when you're trying to go through these things is just discovering all the material, especially when it's something really, really new. All right, so we want to pick up that object. So we're going to have to hold a reference to it, and we're going to have to communicate to the user somehow exactly what we're holding. So it's fairly easy to point at something, click, and put it in a variable for one of the users to see what it is. We're going to add a key holder sphere to the scene right next to our control right here. So we're going to make that change color to reflect what's been picked up. By adding a pick key method to our scripts, we're going to achieve that. Right, so right now, I wish I had a preview, so I'm hoping it's self-explanatory. Let's see exactly what. But here you can see the code that you would add into the editor to assign that key. Very simple one-liners. That's usually most of what you're going to be doing in Unity for the most part. All right, so now to finish, we have to make sure that all the scripts, all the keys, will point to the right key holder, right? So when a key reacts to a click, it will assign itself to the one and only key holder in the scene. Knowing this, when we click on the key, we're going to see our key holder change color. So here's a demo of this. So we're going to move our head, look at the keys, point, like if you pay attention to the key holder, the little sphere next to the remote, and you click on it, it's going to change color. So now we have a way to communicate to our user, hey, you just picked something up. And we can move on to the next part, which is going to be opening doors. All right. So the way we animate things in Unity, so this is what we're going to look at right now. So Unity has a very nice animation system that's perfect for what we're trying to do right here. So here our doors are going to be more like gates. They'll open towards the top, right? So we're going to create first an animation. And to configure this animation, so once we have an animation that's been assigned to an object, we have like a time span here. You go to the end of the graph, you adjust the values to say, I want the Y of this object to be at this height. And that's pretty much all the work we need to do to define an animation. Now you'll note also that in this case, I've created an animation with the property of the color so that the cube that's acting as the unlock, the keyhole was turning white. You can animate pretty much any property. Right? So, and how do you react to clicks? How do you make animations happen? You do this through a state machine in the Unity animator. I think it's also called machine if ever you're looking it up. So Unity's animator allows us to build this state machine, very graphical, very nice little interface. So our door state is obviously a fairly simple thing. It's going to have an idle state on start. It's going to move on to an open state, and then once another click happens, it moves on to close, which will reverse the animation, which will close back to the gate. And then it will revert on its own back to idle mode, where it will wait for further clicks. So let's see what that looks like. Oh yeah. Something I should mention is that when you want to reverse an animation in Unity, you might be wondering how you didn't define like an animation from the top to bottom and vice versa. You just enter a speed of -1 instead of a speed of 1, and it reverses and plays the animation reverse. That's a little trick that took me a little while to find out as a newbie. I hope it's useful to all of you. So that was the final result. Okay, so at this point, sort of short on time to start getting into the Android things side of things. So I'm going to be skipping away from that one today, and I will answer questions for anybody interested in that subject. I have a few things with me. So to close the talk, I have a few takeaways that I want to share with you. A lot of things can be taught to volunteers, so that people who are familiar with in some respects with technology. But a lot of what we see today is usually quite learnable by somebody who's really, really new to all of this stuff. Everyone can help because of this, right? So kids, adults can help either with the programming or with model making, with electronics, with wiring. We've seen how we've basically leveraged kids to paint headsets, for example. So all these things in community projects like that can get everybody involved. It's a very, very rich environment for growth for everyone who's involved. And the actual result of the project, in our case it was hospital visits, in your case it might be something else, is also obviously something that's doing social good to the world. So building a social and experimental platform makes both the process and the result worthwhile and impactful. And I can tell you from first experience that it's a wonderful feeling to be involved in something like that. That's it for me today.